Welcome to the Deep Dive. Today, we are really getting into some classic RC action. We're talking about those legendary 80s Tamiya buggies, the Grasshopper, the Hornet, Super Hornet, that whole family.
Absolute icons.
Right. But our mission today is a bit specific. We want to figure out how to make their drivetrains, well, bulletproof enough for modern, powerful motors.
Because that's the core problem, isn't it? You drop in something potent, like a modern brushless, or even a hot brushed 540.
And bam, strip gears, constantly.
Exactly. Those motor mount screws just work themselves loose, the mesh gets sloppy, and, well, plastic gears don't last long after that.
So you've looked into this across these different models. What's actually causing this? Is it just vibration?
It's a bit more complex than simple vibration, actually. We're looking at what I'd call a dual diagnosis, two distinct mechanical issues working together.
The dual diagnosis. Okay, lay it on me. What are these two issues?
So number one is something we call gearbox slap. You know how these buggies have that pivoting rear axle, the whole gearbox assembly?
Yeah, it's live axle setup.
Right. When you hit the throttle hard, all that torque makes the entire gearbox assembly pivot upwards really violently.
Until it hits the chassis.
Until it slams against the chassis. Stop, yeah. Think of it like a little hammer blow over and over again. Huge impact forces, high Gs, every time you accelerate or brake hard.
Wow. So that initial shock, that slap, is maybe even more significant than just the motor spinning. It's knocking the screws loose.
Precisely. It's a major contributor. And then there's the second issue, gearbox flex.
Flex. Where's it flexing?
The plastic end plate, you know, the part the motor actually bolts onto. With a stock motor, it's fine. But put a powerful 540 in there with all that torsional stress, and that plastic plate actually deforms. It twists just a tiny bit.
Just enough to mess up the gear mesh.
Just enough. So even if the screws were tight, the mesh isn't consistent under load. That allows things to shift, and eventually the screws back out.
Okay, so we've got impact and flexing undermining the whole thing. Makes sense. Now, before we fix the slap and the flex, people often reach for thread locker. Big warning sign here, right?
Huge warning sign. This is absolutely critical. You must never use standard anaerobic thread lockers on these Tamiya plastic gearboxes.
Like the blue or red Loctite stuff everyone has.
Exactly those. They contain methacrylates, and these chemicals actually attack the ABS plastic Tamiya used. It's a chemical reaction.
Attack it how? Like melt it?
It makes it incredibly brittle, weakens the screw bosses significantly. But even worse, the way these thread lockers cure involves expansion.
Expansion. Inside the plastic.
Inside the plastic screw hole, yes. It creates tiny stress cracks. You're basically destroying the gearbox housing from the inside out, just trying to keep a screw tight. Permanent damage.
Yikes. Okay, that's terrifying. So what do you use if you need some chemical help against vibration?
You need something specifically designed for plastics. Usually these are low-strength cyanoacrylate-based adhesives. Think Loctite 425 Assure, or maybe Vibratite 325.
So like a specialized superglue almost?
Sort of, but formulated to be plastic safe and provide just enough vibration resistance without causing that chemical damage or expansion stress. It secures things against any residual vibration once the big mechanical issues are solved.
Gotcha. So plastic safe adhesive is step one. But it won't help if the gearbox is still hammering itself. Yeah, right. How do we kill that slap? Priority one, you said.
Priority one, definitely. You have to stop that violent pivoting motion. The best way is a dedicated transmission brace.
Like a third link?
Exactly. A third link connecting the gearbox to the main chassis tub. It triangulates the structure, stops the pivot, makes it stable.
And for the simpler buggies, like the original Grasshopper?
For those, even the basic DIY anti-slap mod helps a lot. It's essentially just putting a well-placed screw or stop in the chassis tub to limit how far the gearbox can pivot upwards. Reduces the impact force dramatically.
Okay, so brace the transmission. That stops the hammering. Now, what about the flex? How do we stiffen up that motor mount plate?
Here, the best solution is replacement. You swap out that stock plastic end plate for a CNC machined aluminum gearbox end plate.
Ah, metal. Much more rigid, obviously.
Vastly more rigid. It completely eliminates that flex, keeps the motor perfectly aligned, ensures a constant gear match no matter the load, rock solid foundation.
Does the aluminum plate do anything else, like maybe dissipate heat? Those modern motors get hot.
Oh, absolutely. That's a major secondary benefit. It acts as a fantastic heat sink, pulling heat away from the motor can and the gearbox internals. Crucial when you're pushing serious power. Keeps things much cooler.
Right. And one last piece, the kind of system-wide upgrade. Ball bearings. How critical are they here?
I'd say essential, really. Replacing the stock plastic or brass bushings with a full ball bearing kit does more than just reduce friction and heat, though that's important.
What else?
It eliminates slop. Those bushings wear and allow a tiny bit of wobble in the shafts and gears. Ball bearings are much more precise.
And that wobble transmits vibration back to the motor mount.
You got it. It's another source of destructive vibration and kinetic energy shaking those motor screws loose. Bearings smooth everything out.
Okay, so pulling it all together for you listening, this isn't just one fix. It sounds like you need a combined approach for real reliability with big power.
Totally synergistic. You need the brace to stop the impact slap, you need the aluminum end plate to stop the flex and keep the mesh true, and you need the plastic-safe thread locker to handle any leftover vibrations. That's the trifecta for a truly bulletproof setup.
Right. Attack all the failure modes. Makes perfect sense. And that brings us to a final thought for you to consider. Isn't it interesting that perhaps the simplest, most efficient upgrade, the ball bearings, works by reducing the very forces, the slop and vibration, that make the brace and the aluminum plate so necessary in the first place? It shows how just cutting down friction fundamentally boosts the entire system's lifespan. Something to think about.